Hello students, today we will discuss about dimensional formulas. Dimensional analysis. This is the important topic of first unit. We know that we have two types of quantities. One is fundamental and second is derived. So when we represent any derived quantity in term of fundamental quantity, then that relation gives the dimensional formula or dimensions. For example, if I am taking volume, so volume is a derived quantity and we can represent it as length power 3 because length is fundamental quantity. So dimension formula for volume becomes length is represented by L, so L cube within square bracket. This is dimensional formula for volume. If I am taking another example, that is density. Density is equals to mass by volume. So density is our derived quantity, mass is fundamental, but volume is again derived. So we can write mass, that is represented by m, divided by volume, that is equals to L cube. So for density I have a formula m power 1 L power minus 3 within the square bracket. So this is the dimension formula for density. One more example. Now work done. Work done is equals to force into displacement. Here displacement is a kind of length, that is fundamental, but force is not fundamental. So I will write force equals to mass into acceleration. Into displacement I am writing as L. Mass is fundamental, acceleration is not fundamental. So acceleration we need to drive v by t, velocity by time, into L. But velocity is again derived, so m into v is L upon t, so it becomes t square into L. So overall work done is equals to mass into L square by t square. So I have a dimension formula for work done equals to m1 L2 t minus 1. This is dimension formula for work done. So now with help of these examples, we can see that dimension formula is representation of any derived quantities, in term of some powers of fundamental quantities like m, L and t. Basically we are taking these three things, but we can take another as well, as ampere for the current and mole for the amount of substance, like these. So I am writing a definition of dimensional formula. Dimensional formula is the expression of any derived quantity in term of fundamental quantities m, L, t, etc. with some powers of these, right? and these powers are known as dimensions, right? For example, dimensional formula for volume is equals to L cube. Dimension formula for density is m1 L minus 3. Dimension formula for work is m1 L2 T minus 2. And dimensions of volume is 3, and dimensions of density is 1 and minus 3. And what about dimensions of work? 1, 2 and minus 2, right? Another thing is dimensional equation. What is that? Here I wrote dimension formula for volume. This represents the dimension formula. This is for density, and similar this is for work. These represent dimension formulas, but if I write left hand side in square brackets, then it becomes dimensional equation. It shows dimensional equations. These are dimensional equation. Okay. Next is we can derive any dimension formula with help of given derived unit or with help of its unit only. Say for example, I am having unit of G is Newton meter square per kilogram square. It represents universal constant, that is gravitational constant, and I have to write the dimension formula for capital G, and I am provided with this unit, Newton meter square per kilogram square. Okay, Newton stands for force. Newton is the unit of force. So dimension formula for force is m1 L1 T minus 2, or you can derive it by your own. Meter square, that is L2. Kilogram power minus 2, so m power minus 2. Then if I combine these three, m1 L1 T minus 2 into L2 into m minus 2, so I'll get m minus m, total power is 1 and minus 2, L power 1 and plus 2 and T minus 2. So overall I'll get m power minus 1, L power 3, T power minus 2. So this is the dimensional formula for the universal constant G. Fine. Next is types of quantities. Types of quantities. We have 4 types of quantities. One is dimensional variables. Second is dimensional constant. Third is dimensionless variable, and fourth is dimensionless constant. As the name given, dimensional variables, so those variables means with varying values having dimensions. So what are the dimensional variables? Those variables which are having variable values and having dimension formula as well. So dimension formula plus variable values. For example, length, mass, force, density, work done, etc. Most quantities. Next is dimensional constant. So it is having dimension formula plus constant values. For example, universal constant G, gravity, Avogadro number, etc. So these are our constants but having some dimensions. Next is dimensionless variables. So no dimension formula but variable values. So for this we have angle, strain, okay, or you can take refractive index. Because these are the ratios of same quantities. Angle is equals to length of arc upon radius of arc. So length and radius are the same quantity. Strain, that is also original configuration to the change in configuration to the original configuration. Refractive index, speed of light in vacuum to the speed of light in given medium. So these are some quantities with ratio of the same quantities. Next is dimensionless constant. So no dimension formula but values are constant, that is pi, 1, 2, 3 up to so on. So these were our 4 types of quantities, 2 dimensional and 2 dimensionless, variables and constants. Now next topic is principle of homogeneity. Principle of homogeneity means this is the important topic for the applications of dimensional analysis. So principle of homogeneity state that we can add, subtract or compare the quantities those which are having equal dimensions. So this principle state that same quantities, same types of quantities can be added, subtracted or compared. Okay, for example, I have length and I can add length in it. I can't add area in it. So if I add 2 length, then I'll get only length. I can subtract and I'll get length. There is one more point. Suppose I have an equation m power a, l power b, t power c. This is the dimensional formula of any physical quantity, and m power x, l power y, t power z. This is also dimension formula of same quantity but in other system of unit. So according to principle of homogeneity, we can compare these two if they are having the same quantity. Okay, so by using principle of homogeneity, I can say A is equals to X, B is equals to Y, and C is equals to Z. This one, right? So this is your principle of homogeneity. Next we have applications of dimensional analysis. Applications of dimensional analysis. We have three applications. One, to check the accuracy of given formula by using dimensions. Next, to convert one system of unit into other system. And third, to derive the formula. These are three most important applications of dimensional analysis. So for now I am taking the first one, to check the accuracy of the formula. Suppose I have a formula that is equals to T equals to 2 pi under root L upon G. This is a time period of simple pendulum. So for left hand side, what is the dimension formula for T? That is T1. In right hand side, this is 2 pi, that is constant, that is dimensionless. That is dimensionless. And dimension formula for L is L1. Dimension formula for G is acceleration due to gravity, having unit meter per second square. So it is meter per second square, means L1 T minus 2. Fine. Now T, that is T1, that is left hand side, and right hand side I have L1 divided by L1 T minus 2 whole power 1 by 2. Square root means power 1 by 2. So I can cancel this L1. Then I have T power minus 2 as a denominator. Then I will shift it to T power 2 whole power half. So then I have T power 1, that is equals to right hand side. So from 1 and from 2 we can say that left hand side is equals to right hand side. So given formula is correct. Okay, so these are the steps. We have to verify whether left hand side and right hand sides are equal or not according to dimensions. So another example is here for the same application. I have a formula. I am taking a general formula, that is S is equals to ut plus half at square. Okay, for left hand side I have S is displacement, so displacement is L1. U is having velocity, that is L1 t minus 1. T, I have time, that is t1. Then I have a acceleration is L1 t minus 2. Then t square, that is t2. For right hand side, I'll be having u into t, speed into time. So I have u into t, that is t1. So I can cancel this one, plus I have half is dimensionless, so acceleration is L1 t minus 2 into t2. I can cancel this one. Overall I'll get L1 plus L1 here, and according to principle of homogeneity we can add, subtract or compare the same quantities. So if I add these two, then I'll get L1. So this is our right hand side, as left hand side is equals to right hand side. So given formula is correct. Okay, that's it.